Welcome to The Explainer. Today, we're diving into something truly wild. We are looking at a fascinating piece of source material that tackles one of the biggest philosophical debates of our time. Do artificial intelligence systems, like large language models, actually have human-like attributes? I mean, do they feel anxiety, empathy, or understand morality? Well, to answer that, the author of this paper uses a totally unexpected tool. They use a 1999 retro strategy video game to completely unravel the magic of AI. It's a brilliant, mind-bending paper, and by the time we're done, the way you look at chat interfaces will be fundamentally changed.
Okay, let's quickly lay out our cognitive roadmap for today. We're going to cover 5 main areas. First, the illusion of AI minds. Second, AI and Age of Empires. Third, the substrate problem. Fourth, the circular research trap. And finally, the null assumption.
Section 1. The illusion of AI minds and how we project humanity onto code.
To start, we really need to examine how our natural instinct to understand complex things leads us into a massive psychological trap. And to understand this trap, we have to ask, does Age of Empires 2 have feelings? I know, it sounds absolutely absurd to ask if a decades-old computer game about building castles has feelings. But stick with me, because by the end of this explainer, you'll see exactly why this is actually the most important question we can ask about modern AI. It all boils down to this one concept, anthropomorphism. That's our tendency to project human traits, like anxiety or empathy, onto non-human things. Because AI systems are just so incredibly good at mimicking human conversation, it is dangerously easy for us to anthropomorphize them. We build relationships with them, we treat them with respect, and we project real emotions onto what are essentially just giant piles of math. And honestly, the companies building these models often intentionally design them to use words like "I believe" or "I feel," which only deepens the illusion.
And get this, it's not just everyday casual users falling for this. The author of our source paper actually surveyed 315 recent AI research papers. They found that a staggering 57% of them start by implicitly assuming large language models already have human-like attributes. Even top-tier computer scientists are falling into the trap of using human psychology to explain machine behavior.
Section 2. AI and Age of Empires, Building Neural Networks with Virtual Goats.
So to prove how flawed our assumptions really are, the author leverages something called Turing completeness. That's basically the idea that any sufficiently complex rule set can run any computational logic. And the author proved this by literally building a functional NAND logic gate entirely inside the Age of Empires 2 game editor. In this incredibly clever setup, the game's terrain itself is the circuit. A patch of grass is a mathematical 0, a bridge is a 1, and those little virtual goats wandering around, they are literally acting as the signal carriers, or the data bits. The author built the foundational building blocks of a computer out of medieval game assets. And they didn't stop at just one logic gate. By linking these Go-powered gates together, the author successfully trained a basic neural network component called a perceptron entirely out of in-game structures. When you look at the massive in-game pen of logic gates side by side with an equivalent neural network circuit diagram, it proves something profound. It proves you could, theoretically, build an entire large language model out of virtual goats. If you had an infinite map and 0 computing limits, this game could run the exact same math as the most advanced AI chatbot today.
This brings us to a crucial point: substrate independence. An AI is, at its core, just math. And it absolutely does not matter if that math is running on highly advanced silicon chips in a data center or if it's running on a network of virtual livestock moving across grass and bridges. The mathematical output is exactly the same.
Section 3. The substrate problem, or how interfaces fool our minds.
Here's where it all clicks into a massive philosophical problem. Imagine you type the prompt, "I am lonely," into a sleek chat window. It instantly replies, "I'm sorry to hear that. Maybe you should call a friend." It feels deeply human, right? It sparks immediate empathy. But what if you feed that exact same prompt into our Age of Empires AI? You would literally sit there for hours, watching digital goats slowly wander across bridges to process the math, before it finally spits out that exact same text response. Suddenly, the illusion of empathy completely vanishes. The empathy was never in the math. It was a trick created by the sleek, fast interface.
The author drives this home with a fantastic thought experiment. Imagine we recruit all 667,000 citizens of the greater Boston area. We give them some rules and ask them to manually process an AI's math by sending text messages to each other, acting like human logic gates. If this giant city computer eventually outputs a text message that sounds anxious, would we ever assume the city of Boston itself is feeling anxiety? Of course not. We'd realize the anxiety is just a pattern of text. This proves that human traits are ascribed by us, the observer. They are projections, completely detached from the substrate running the math.
Section 4. The circular research trap and the danger of assuming AI emotions.
So what happens when actual computer science researchers fall for this illusion? Well, their experiments get totally wrecked. If a scientist designs an experiment and implicitly assumes the machine inherently holds human traits, their test is ruined from the start. Here's why. If they hypothesize an AI has morality and the test result is positive, it's just circular reasoning. They found exactly what they baked into the design. But if the test is negative, it's totally uninformative. Did the test fail because the AI doesn't have morality, or did it fail because the scientist designed a flawed test? You literally cannot test for intrinsic human traits if your testing framework fundamentally assumes they already exist. You're just testing your own assumptions.
Section 5. The null assumption, a better way to study AI.
To escape this trap, the author proposes what they call the null assumption. It's a strict mandate. We must measure an AI system's observable behavior without making any assumptions about underlying human attributes. We have to explicitly separate what an AI practically does, like generating a really coherent string of text, from what we believe it feels. We just have to drop all assumptions about self-awareness, inner experiences, or consciousness and stick to the causal mechanisms of the math.
There's this beautiful adaptation of a classic rule from animal psychology known as Morgan's canon that summarizes this perfectly. In no case is a machine's activity to be interpreted in terms of higher cognitive processes if it can be fairly interpreted in terms of processes which stand lower. Basically, if a chatbot says, "I am sad," we shouldn't assume it has achieved deep emotional awareness, when a much lower process, like statistical pattern matching across a massive database, perfectly explains the output. We have to stay grounded.
And that brings us to the end of our explainer today. I want to leave you with this final provocative thought to chew on. Next time you're interacting with a chat interface that's trying really hard to convince you it's human, the next time a chatbot tells you it feels lonely or anxious or happy to help, are you going to see a conscious digital mind, or are you just going to see the underlying math, a very fast herd of virtual goats wandering across a digital bridge? Thank you so much for joining us. Keep asking questions, and we'll see you next time.